Hello, good morning, everyone. Can you please let me know if you can hear me well?
Good morning. Yes, we hear you.
Okay, wonderful. So, there are 20 of us, and I think we can start our first lecture on data mining. Congratulations. We are starting a very exciting topic. So, let us discuss in the first place what is it all about, what the data mining is, and what we are going to do. So you have probably had already some data-oriented modules in our Innopolis program. So I presume you have had something about databases, maybe something about machine learning, maybe not. So could you please let me know which data-centric, I would say, data-centric modules you have had already? Anything dealing with big data processing. It could be databases, it could be something about big data, it could be about machine learning. So what have you got already, if
We
anything?
had two courses for databases. We have big data course, and we had like introduction to machine learning.
Oh, wonderful, wonderful. So in that case, it is actually quite important and at the same time not very easy to say what the data mining is about. So databases, we know what the databases are. They provided some kind of underlying machinery which allow us to store, retrieve, and process data. Right? So it is more about the technology, underlying technology, which allows you to deal with big or maybe not so big data. So presumably you learned about, first of all, relational databases in the first place, and then maybe about some key value and other NoSQL databases, maybe about distributed databases, such as maybe Apache Cassandra, Spark technologies, Hadoop technologies, something like that, probably. MongoDB, NoSQL example. So that's about, I would say, the machinery, the methods related to data storage, retrieval, processing. Okay. On the other hand, you have had, as you said, the big data module. So could you please remind all of us what this big data was about?
It is about like how to handle big amount of data. We studied like Hadoop and Spark and like how to process data on a distributed system.
Okay. So this large-scale distributed databases like Hadoop, Spark, and so on, they were precisely the part of big data. Okay. So is it correct to say in that case that big data was also about database technology primarily, only in a distributed environment suitable for storing and processing of very, very, very large amounts of data. But basically, it was not about data processing methods and algorithms, but it was about the technology in the first place, like databases primarily for relational SQL-based ones, and big data about NoSQL key-value distributed databases. Is it correct to say that big data was about databases as well, only distributed databases?
Yes.
So it was not about data processing, I would say, algorithms, tasks, business orientation, and so on. So did you ask, for example, questions like that? A company I don't know, a retail company, a large retail company like X5, for example. You have all heard about X5, I presume. Magnet, which we have in Innopolis, I think is also part of X5. They daily generate huge amounts of data, all information related to retail operations, goods sold, prices, inventory, stockpiles, logistics, delivery, wholesale purchases, and so on. All these data routinely come in gigabytes or maybe even in terabytes per day. Well, really in large gigabytes. Okay, so these data are coming. So what your data, I would say not database, but big data course was actually doing? That's an interesting question. Uh, you were talking about how to store this data efficiently, for example, or what kind of algorithms could be applied to these vast amounts of data in order to enhance, for example, business efficiency? Was it more about the first kind, I would say the technology, the underlying technology, or it was about the business applications of those big data, so how to use them for business purposes?
I would say mostly the first one. Like the algorithm itself didn't matter as much as how we handle the data and the pipeline of storing and using the data.
Okay, okay. So then it makes sense. Okay. But in addition to that, you have had the machine learning module, or maybe even more than one. And in machine learning, you definitely asked and we're asking and answering these questions about, okay, you got the data, possibly you got very large amounts of data even, and now really what kind of inference we can make from those data, all right? So we can draw this type of picture, because if we have yet another data-centric model now, which is data mining, we really need to understand why we need it in the first place and what it is all about. So let me put it in a schematic drawing like this. You can see my hand drawing, right?
Yes.
So, excuse me that it is not ideal. I will try to make it better. So, first of all, you have databases. And databases are presumably SQL. Well, mostly. Okay, so these are about, let's say, SQL relational. So these are about the principles of relational databases, as we know, tables, normalization, and then typical standard requests. First of all, abstract operations based on operations on relational databases, and then how it is implemented in SQL. So something like this. Okay. Then we have something even bigger than that, and most importantly, not just bigger, but distributed. We have this big data. Uh, and I would say relational, centralized. Big data, let's say all these Apache, let's say Hadoop, Spark, Cassandra, and so on. So which are typically key value, not necessarily, but typically NoSQL, and most importantly, distributed. That's about big data. But still, this is more about the technology side, actually, how to deal with this data. Okay. On top of that, you may have machine learning. Machine learning is really about the algorithmic side. So machine learning is about, let's say, non-linear inference. Well, maybe linear, but in general, let's say linear, non-linear, primarily non-linear inference, inference algorithms. So if you got this data, what you can really make of it, not just store huge amounts of data to no avail. And by the way, this is a very typical error made by a large number of companies. They do have large amounts of potentially useful data available through day-to-day operations. They do store this data, but they do not make any useful inference from it. So, for example, a retail network may have huge amounts of retail data coming from everyday operations, but they are not using this data possibly for any kind of optimization or improvement of retail practices in order to improve their competitive position. So the key word here is inference, linear, nonlinear inference algorithms. Uh, Machine learning may refer to data stored in conventional centralized databases, but more and more, with the amount of data increasing, machine learning would be using those big data technology in order to provide the underlying layer for data storage and data processing. So all these are actually about storage, retrieval, in place, inside the database, I would say, in place processing. Okay. And in either machine learning or databases or big data course, you have probably heard some terms like, well, database first of all, of course, and then something like data mart and data warehouse. Have you heard these terms?
Yes.
So what is it? So what is the difference between database, data mart, data warehouse? Or is it just, a business
Could you
talk?
please write second term like letter by letter? I don't listen.
Yes,
Mark?
the terms are obviously the first one is database. We all know this. This probably doesn't require any clarification now, but also there are terms data mart and data warehouse. So my question is, what are these two? You said you have heard something about that. So what is it?
Data warehouse is just some large amount of data from one company, I guess. Like
Okay,
all of it in like together.
okay. And data mart?
Uh, Honestly, I googled right now, and from what I understood, it's just specifically oriented part of data from data warehouse?
Well, maybe. This terminology is quite flexible, and I don't think there is even any single meaning assigned to it. I would say that database, data mart, data warehouse are primarily just different scales. So if the scale is not extremely large, then we are talking about a database. Database can by itself consist of a very large number of tables. Apart from just database and table, it may have some intermediate levels of structural organization. So for example, an Oracle database instance uh, has a very, I would say, complex internal organization and can be relatively large, definitely going into terabytes, maybe tens of terabytes of data still. When we increase the scale further, then we're talking about data mart. And although this term, it was very popular, let's say about 20 years ago, when really transition was made from individual databases to collections of databases, because a single database couldn't handle that amount of data. And then we were talking about the data mart. And then when the scale is increased even further, then we're talking about a data warehouse. So it is just a question of scale. Whether, for example, for your retail network, the data organization would be called, it is definitely not a single database, it would be larger than that. Whether it would be properly called data mart or data warehouse, I think it is more just a matter of taste. So still, we can draw the same scale line here. So individual databases are here. They're databases. Data marts. So this is DB. Data marts and data warehouses are to the right. So a data warehouse is typically, not always, but typically implemented using this big data technology. So conventional, relational, fully centralized databases are typically insufficient for a data warehouse, and that's why this big data technology comes for help, and the data warehouse is implemented using this big data. Whereas data mart would typically be associated with more traditional database, scale database technology, but it would be at a large scale, at a large end of conventional database technology. So just multiple instances connected through some kind of middleware, perhaps multiple instances of Oracle DBs, each instance huge, well, very big on its own, and interconnected using some kind of middleware, for example. That would be a data mart technology. And taking the scale even further, we're going into big data technologies used to build this data warehouse. Okay, so I think this is useful. We put what we have learned already into some kind of picture showing entities and relations between them. So we already know that these terms are somehow systematized and connected to each other. Okay, so but we're now going to talk about data mining. So what is data mining? Any ideas? Before we really give a definition to data mining, and interestingly, this definition would be Little bit counterintuitive and possibly different from what you could think of. Let us assume, having seen already these databases, big data, data marts, warehouses, and even machine learning. So let's guess. What would be your guesses where data mining comes into the picture and where is it in this picture? What do you think?
My guess is, how do we get the data? Like, for example, like from websites, or like when there's a lot of users using something, how do we get data from them? Something like this.
Okay, so if we say data mining, what you can say, this is first of all about some kind of data sources. So there are data sources, and these data are coming, for example, into our big data storage, but we really need to mine this data from sources so that we populate our big data warehouses with data coming from sources. So mining is about, as you say, from the definition as I got it, mining is actually sourcing of data and they come from external sources, all right? Something like that?
Yes.
Okay, which is generally correct. We will explain some maybe differences, maybe some interesting features of data mining shortly, but generally it is correct. So data mining is, at least as one of the important objectives of data mining, yes, it is to provide sourcing of data and populating our big database. Actually, when I heard about data mining first, not even knowing at that point what it is all about, my intuitive feeling was slightly different. So my intuitive feeling was that all kinds of raw data, completely unsystemic, are already put into our big data storage. So assume that this big data is already swamped in a completely unsystematized way with the raw data coming from all possible sources. They're coming and coming and coming. So for a retail company, the data are coming from, as I said, for example, all till machines, retail operations, barcode scans in inventory from logistics companies which deliver goods to retail warehouses, from financial transactions, uh, both actually banks and well, information coming from banks on payment operations, information, retail payments, information coming from banks related to wholesale purchases, other operations, and so on and so on. So all this huge mass of data are put into this big data, and now we are trying to make some use of it. So we are really trying to mine useful knowledge out of this big mess, and we're trying to do some kind of inference. So from that point of view, data mining is probably some kind of machine learning. You are you got huge amounts of unstructured data. You don't know which data are useful, which data are not so much useful, but you collect them all, you dump them all into these huge databases, and then you're asking the question, okay, and what can we make of it? And you are trying to really mine some useful grains of knowledge, for example, which would allow you to make some kind of inference, prediction, useful business logic out of these huge amounts of data. So in that case, data mining would be finding useful knowledge out of huge amounts of unstructured and otherwise not so much useful data. So these are two different points of view. So one of them, as proposed by you, you said that data mining is not mining in our big data, but it is mining in the outside environment in order to populate this big data, right? So that's one definition. Whereas another definition, which I made, is slightly different, that data are already in our big data storage, and we're now trying to mine important knowledge, useful knowledge out of it. And in that case, data mining is some kind of maybe just primitive ad hoc, but some kind of machine learning, which we apply in order to make any first hand useful application of this data. Okay, so
Could I ask a question?
yes, yes, please.
So you said that mining is kind of about gaining knowledge about data that
Well,
you
I did not say that assertively yet. I only said that there are two possible points of view. One about data acquisition in the outside environment, and another one about inferring important knowledge. So which of them is correct? I didn't say yet. I just said that there are two possible understandings. Okay, and your question is?
So about second understanding, how it could be called data mining if knowledge gaining is not about data, it's about information. So if we refer to the definition of the data and information, you could see the data is nothing about the knowledge. So we cannot get some new knowledge with data, but with information we can, because information brings some new ideas, knowledge, if we can say like this.
Well, in general, you are right. So if we distinguish between the data and information, then yes, you are absolutely right. So by data, we really understand this raw, unstructured, unsystematized data which are merely stored, but which do not represent any information as we know from the information theory point of view. And then knowledge is precisely information extracted from that data. And in that case, data mining is not equivalent. You say, okay, it could not be this way, as you say, because data mining means that you mine data rather than mine information or knowledge. So in that case, you say the term data mining itself precludes, makes it impossible to use my second understanding. So if we mine data rather than information or knowledge, then it is only this first definition which is applicable, but it could not be the second one. That's what you say, correct?
Yes, but maybe I'm mistaken. I just wondering.
No, you are right. In general, you are right. So if we really strictly distinguish between information and knowledge on the one hand, and data as unstructured and yet ununderstood data on the other hand, then data mining could only be this. And this would be information mining, which is not the same as data mining and then not applicable. But interestingly, in reality, it is both actually, one and two. Data mining is I would say, loosely defined, some kind of intermediate, I would say, discipline or activity or area which is concerned with the following. What are the objectives of data mining? So first of all, the objectives of data mining are really in data acquisition, but I wouldn't say that it is data acquisition by itself. So for example, if we installed various kinds of camera sensors and so on everywhere, okay, let me continue this retail example. The retail company is concerned with some kind of financial losses which are identified at top level using, you don't even need machine learning algorithms, you apply some, I would say, very rough big data processing algorithms, and the company finds out that the total, let's say, if in financial terms, the company calculate the cash flow differences, so it pays for, first of all, purchase of wholesale goods. So, for example, buying groceries, buying foodstuff from the farmers. All other expenditures related to logistics, transportation, storage, uh, obviously all salaries paid to the staff, uh, renting the retail spaces, and so on and so on. So all expenditures appear to be greater than the retail revenues. Obviously, this requires some explanation. Maybe some indirect expenditures are too high, for example, for logistics, maybe for salaries. But let's say it is not, because the company was operating in about the same mode for years, and in general, all was in balance. But for some reason, retail, retail, let me even make it more precise. Retail revenues, retail income is decreasing. Let's say all expenditures are about, this year are about same level as previous year, but the retail income is decreasing. You could say, okay, this is due to unsold goods. In that case, the stockpile, the inventory, the stockpile of unsold goods should be increasing. Okay, all right. So somewhere in the warehouses, not data warehouses, but physical warehouses of our company, the stockpiles of unsold goods is growing, but it is also not the case. So the retail income is decreasing. All expenditures are about same level as previous year. Stockpiles, inventories are not increasing. And a very, let's say, top level economic analysis, you don't even need to call it machine learning. It's not about machine learning. It is about just very conventional database operations applied to big data. The company does it, and it observed this. So let's say uh, expenditures. More or less same level as before. stockpiles, inventories. Also more or less same level as before. Retail revenue is down. Any ideas why this could have happened? Let's brainstorm the situation. We don't know yet.
Probably because the prices for the products decreased in the magazines.
Good point. So this could be due to retail revenue is decreasing because you are selling same amount of goods, but at a lesser price. So one possible explanation is that the prices are down. But upon investigation, suppose that, so this is a very reasonable hypothesis to test. For example, we are testing year 20 against, okay, year 20 is just finished, so we don't have much data for year 21. So we are testing year 19 against year 20. For year 20, the statistics is just out. We have complete data for year 20, and we're observing this unpleasant situation. Prices are down, maybe. But upon investigation, again, we run queries on our big data, and upon investigation, it turns out that it is also not the case.
Sorry, maybe then that it is because the company didn't adapt to the inflation.
I could not hear you quite well. Could you please repeat your point? Little bit more loudly, please. I couldn't hear you. Anyone else? Any ideas? Why could it also have happened? Any reasons?
Okay, do you hear me now?
Yes, I do. Yes.
Yes. Okay, so can it happen because the fact that the company's prices for the products are the same, but the price for the price for the currency in the country changed because of inflation, and for that reason, the prices in current currency exchange are the same, but the company makes less money because they did not look well for the inflation.
It may be. It may be. So as one of the possible examples, if our retail company is selling even foodstuff which is not locally produced, but let's say imported from abroad, from other countries, due to devaluing of our local currency, this would mean that for the company, the wholesale acquisition of goods, let's say imported from, for the sake of the argument, let's say from China, is now more expensive than it was a year ago. So it is definitely possible. But we have already ruled it out because we say that expenditures possibly adjusted to currency inflation or deflation are more or less the same. So probably also not. And you see, that's precisely what the board of the company would do as we do it now, a brainstorming session in order to understand what could be a potential reason. And you know what? Someone proposes a very strange, unexpected, unlikely, improbable, but nevertheless possible course. Very sorry to say that, but what if the reason is simply shoplifting being on the rise? You know, this could explain absolutely everything. Expenditures are roughly the same, inventories pre-sale are about the same, even prices are not falling, but the retailer revenue is down simply because a larger proportion of goods is merely not paid for. Instead of being paid for in retail stores, it is just lifted from retail stores for zero price. Is it possible? It is not very likely, but it might be possible. So in order to test this hypothesis, we decide how can we test it. This is just an idea. What do you think should we do in order to test this hypothesis?
Maybe some testing, statistical testing, like A/B test.
We will do a very simple thing. We will install extra cameras in our retail spaces. Cameras may be even with some kind of automated software which may detect shoplifting attempts. For the moment, our objective is not even to stop it because we are not even completely sure whether this is the main culprit. Maybe something else which we are not even completely sure about that. But this is a hypothesis which we need to test. So we install cameras, and cameras provide images. These images are maybe, let's say, snapshots obtained from each camera every second. Okay, where are they coming from? In general, these images are data. They are not like financial data, for example. They are not numerical. These are image-based graphical data, which are also stored somewhere in our big data warehouse. Those cameras installed in the retail places also produce data. That's what they produce. And then we'll probably apply some kind of software in order to, because there are so many cameras, or maybe we even hire a human team which manually going through these images in order to count the number of identified shoplifting attempts in order to see whether it is a really widespread phenomenon and it could be responsible, could potentially be responsible for decreasing revenues.
Well, sorry, I have a question then.
Yes.
If this is a case and we want to test this hypothesis, so the hypothesis we want to test is that the amount of shoplifting is increased. But to test this hypothesis, we need to see that we need to get two types of data. The data about shoplifting amount before
In
some
19 and in 20, yes, which we can't because we have neither. It is only in year 21 when we decided to install the cameras. You're absolutely right. So we can't test this particular hypothesis that really the amount of shoplifting increased from 19 to 20 because we have absolutely no data related to that. But we can formulate an alternative hypothesis, all right? And an alternative hypothesis would be that we count the number of shoplifting attempts. We somehow count now. We somehow extrapolated, maybe multiply it by, I don't know, by 2 or something like that, to account for potentially unidentified ones per unit of time. So for example, we did it for a month in January, February this year. Then we estimate the loss due to shoplifting based on this camera information, and we are trying to understand whether the magnitude of this loss could be roughly of the same scale as this differential in revenue. So we have a negative delta of the revenue between 19 and 20, and we're trying to figure out whether the amount of shoplifting we identified and maybe somehow extrapolated could be of roughly the same scale. So if we obtain a roughly comparable figures, then it is a very plausible explanation. If we say that even when the number of attempts is multiplied by 2 and we count, because we can see what kind of goods people are stealing from our retail space, we have some idea about the prices, we multiply it by the prices, we get the total figure of losses, and we see that it would still account for no more than 1% of the revenue delta, then it is probably not a reasonable explanation. And then we need to account for other reasons. Maybe we just changed our logistics provider between the years 19 and 20, and maybe losses occur in goods delivery, in logistics, in that process, rather than in our retail spaces. So we would need to identify in the retail and check all our hypotheses related to this retail revenue decline. So you are right, we can't test this hypothesis exactly, although we can test something similar, some alternative hypothesis which may give us some kind of clue whether shoplifting may or may not be responsible for loss of revenue. The point is, when we install these cameras, the data are coming. For example, we have many, if it is a large network, a retail network, we have, for example, 1,000 stores. Okay. We have in each store, for example, we have 10 cameras at least. Each camera sends 1 image per second. And even with the data compression applied, how big this image could be? Even if it is not 1 megabyte, but then still, it's efficient resolution. Suppose that, well, it is definitely no less than 10K, and possibly it is 100K. So let's say it is 100K, 10 to the power 5 bytes. So what is the data size we are going to get every day? 10 to the power 3, 4. How many seconds? 10 to the power 4. How many seconds per day? Suppose that we're open from, let's say, 10 a.m. until nearly midnight, which gives you roughly 50,000 seconds. 5 to 10 to the power 4 seconds per day, 10 to 5, and you know what? It is big. For the whole, from one store, it is not that big actually, but, and still big actually. But for all 1,000 stores, if there are 1,000 of them, it is 5, 10 to the power 13, which is 50, not gigabyte, but terabyte of data. Our images would make 50 terabytes of data per day. Okay? 50 terabytes of data per day. And initially what we do, we simply put all these images into a database. This is data storage, data acquisition and data storage. So my question is, what we just told about, all these process of installing, well, first of all, analyzing the revenue and the structure of the revenue, identifying trends, proposing hypotheses, and testing this hypothesis on the basis of acquiring any extra data, for example, data from cameras. Anything in this process we have discussed, does it have anything to do with data mining? So are there any data mining elements in what we have discussed at this point?
So as I understand, data mining here is to get data from the cameras to have it in big data storage.
You know,
But
interestingly, you are right, probably more or less, but the answer is yes and no. So for example, this business logic, when we analyzed our revenue, business logic and analysis, it is not data mining. Hypothesis formulation and maybe testing. Business logic is just business logic. It does not belong to any of the parts we have discussed so far. A sophisticated, I would say very sophisticated business logic would be part of machine learning. A relatively straightforward linear accounting type unsophisticated business logic doesn't belong to any of this. And it would be just business logic. Okay, hypothesis formulation testing is also part of business logic, and maybe if really, I would say, sophisticated, highly data-driven nonlinear hypotheses are formulated, this may very well be part of machine learning as well, but probably not. So maybe part of ML. Maybe not. Now we're talking about this part. So you say data acquisition from cameras is part of data mining. Interestingly enough, not exactly either. Data acquisition is not really data mining by itself.
yeah, because it's not efficient.
Simply
Maybe
by
data mining is
definition,
called-
you know, it is very difficult even to say why not, but it is typically not considered to be. So if we consider a pipeline, so we first have data acquisition, we acquire data, we have data storage. Data storage, we already know what it is. It is databases, data warehouses, big data. Okay. Data analysis. Data analysis, which is either simple business logic or if it is not so simple, then it is machine learning. And we would say neither of them is really about data mining. So then the question is, what is data mining? What is it all about?
The pipeline of these three.
Data analysis, by the way, this is what we're talking about. It is information mining. Data analysis is information mining, knowledge extraction. Knowledge extraction. So what you said, where is data mining in this picture?
It's as a whole, as a pipeline, it's data mining.
Also not. Interestingly enough, also not. Strangely enough, data mining is here.
So because we need to pre-process all the data to
Yes, you
fit
are
the
absolutely correct. You are absolutely correct. So the points of data mining are the following. So data mining is data preprocessing. By preprocessing, let's explain even more clearly what it means. First of all, it is a data cleanup. If, for example, we got a completely dark image from a camera because the camera is off, then there is no even point about storing this in data storage, or if it got into storage, then this data are to be deleted immediately. So data cleanup typically includes detection and removal of outliers, the data which are immediately clear to be incorrect or useful or useless. Detection and removal of outliers. Another important point in data cleanup is detection of gaps. So a completely dark image from our camera could be treated as, let's say, an outlier, or it could be treated as just a gap in the data, because really this type of outlier means that there are no data. And if we detected a gap, then we have some policy of what to do with gaps, depending on the nature of our data, handling gaps. Okay. Yet another one is data format conversion as a kind of, this is not a data cleanup, it is the second point in our data preprocessing. Data format, I would say data format preprocessing. In terms of our retail storage, it could be that we get, for example, the original data as, let's say, JPEG snapshots already compressed, coming from the cameras, but we immediately apply some kind of preprocessing, maybe even before the data are stored. So sometimes it might be unlikely, but it might be that data mining may even include phases between acquisition and storage, but typically it is in between storage and analysis. That we, for example, if we have the corresponding software, we convert our data into vector graphics by edge detection, and then not only it consumes less space, but data stored in the form of data graphics is immediately much more suitable for subsequent analysis. So this is a possible example, some kind of format preprocessing conversion. Okay. Next. Eventually, we're going to do some kind of data analysis. Data analysis, if not the most elementary, just business logic, but business logic application, but if any machine learning is to be applied, then there is a part of this process, which is a very important part. Where do we start machine learning from? If you remember this from your machine learning course, what do we do first? And arguably, this is not just first, but the most important step in machine learning. What do we do prior to any successful learning?
Split on train and test?
Even before we can create a training data set and start training. We train our machine learning models on what?
Normalized data?
First of all, you are right, on normalized data. And for that reason, let me put data normalization. You are right, absolutely. Thank you for this answer. Yes. Data normalization is also part of data mining, typically. And because we need to normalize data, how we do normalize data? We do this based on some kind of statistics. Normalization typically means that we apply a linear or possibly non-linear transform to our data in such a way that the distribution of our data items, they all come at random, of course, they become as close as possible to normal distribution with zero mean and unit standard deviation. By the way, if our data are images, then we need to devise some kind of data normalization algorithm applied to the images as well. By the way, yes, they should all be of the same frame size, boundaries removed, and so on and so on. So this kind of data normalization, great.
Are we assumed that data is already labeled or not? Or are we just, depending on the task, should we label?
Okay, just a second. We may not need labeling because machine learning could, for example, be, there are several general approaches to machine learning, like unsupervised, supervised, reinforcement learning. So, for example, for unsupervised one, we may not need labeling.
Yeah, but I mean that if our task is required if for our task is required to have labeling, should be labeling included in data mining.
Good point. Just a second. We'll come to that, but good point. Thank you. Data normalization. So the answer, in short, the answer to your question is both yes and no. I will explain why. So data normalization, which is closely related to before we can normalize the data, we need to construct some kind of statistics on this data, descriptive statistics. Once we construct the statistics, so for example, histograms, which represent densities of the distributions, maybe some visualization and so on.
But should the visualization be done first? Because of the visualization, we can find outliers and also the statistics of our.
Serialization, what exactly do you mean by serialization?
Not, I don't say serialization. I said about the descriptive statistics. So we should do it first because finding outliers and detection of outliers, no?
Generally, yes. And you are right. So these tasks, first of all, they are specified in no chronological order because normalization and descriptive statistics are closely related to each other. And yes, statistics would probably come first. You are right. So in no particular order, disclaimer.
Okay then.
You're absolutely right about that. And yes, of course, detection of outliers and gaps is also closely related to descriptive statistics. Typically, it would be done in iteration in a way that you first construct the statistics on the available data, you remove the most obvious outliers, you recalculate the statistics because obviously the outliers would distort the statistics. You remove more outliers and so on until probably the process stabilizes. So this might even be a recursive process. Okay. What else? As you say, labeling. Labeling is the right thing, and to some extent it may, or I would say may not, belong to data mining. My question is, even without labeling, because for example, unsupervised learning doesn't require labeling of data. When we do machine learning, we do machine learning on what? What is the input to machine learning?
Some features, some set of features.
Features. You are absolutely right. Features, not data. So it is feature generation. Feature generation. Then, yes, labeling, if required. And then, obviously, as you said, training sets, verification sets, and so on and so on. So I would say machine learning by itself. So these are steps related to machine learning. The question is, these machine learning steps, are they part of data mining or not? The answer is generally yes, but only simple machine learning. Simple, I would say superficial machine learning. When we got our data, we performed construction of statistics, normalization, cleanup, pre-processing if necessary. Then we do some kind of machine learning on this data, a very, I would say, first-hand approach, not a deep learning yet, but a first-hand approach. And this initial superficial lightweight machine learning, let's say lightweight, is typically also considered part of data mining. I will explain why. Very often, the data which you use in your subsequent really in-depth business analysis and machine learning, these data are not acquired by you, or they are not coming directly as a part of your business process. Instead, you have to buy those data from other providers. Continuing with our data mining example with cameras, suppose that it is not your company which really purchases all these cameras, install them and links them to your data warehouse to store the images. Instead, you hire a security company which does this for you. And then they simply deliver the image data set to you. And they tell you do what you want to do, or maybe even they do some kind of preliminary analysis. Maybe they do have their own specialist software, for example, for motion detection, and they try to identify shoplifting attempts using their own software. So it can be offloaded, it can be delegated to external service providers. And then you pay. In any case, you pay for these activities. You pay for cameras if they're yours, you pay for data if the data are external ones. And your question is, okay, I start acquiring this data. Can this data be potentially useful for me? Should I continue doing so? Should I buy more data? Should I, if, for example, a large number of shoplifting attempts have been identified, should I possibly even install or ask the security company to install more cameras and identify more? Because if this happens nearly just every 10 minutes, then you would really be interested in probably understanding the full scale of this disaster. So the data you are getting and which you are normalizing and preparing for further use may or may not be useful. So in order to understand the usefulness of your data, you really need to run some kind of superficial machine learning or data analysis. And this preliminary superficial analysis is also part of data mining. It is not the final ultimate use of your data, but it is primarily to decide whether the data are useful.
What do you exactly mean by superficial ML? So how we can define it?
No way to define it formally.
For example,
Unfortunately,
which methods we can use in this?
typically you would use same methods as in general machine learning, but to some kind of lesser extent. So, okay, suppose that in machine learning, you use some kind of neural nets, for example, to analyze your data. You can either build a very big network with thousands of nodes and maybe 30 layers with fully connected layers interchanged with convolution layers and so on and so on, and then optimize this layout using reinforcement learning. As you know, image recognition is a difficult task. You probably know it from your machine learning course, and typically deep learning in which fully connected layers are interleaved with convolution layers, and convolution layers are typically responsible for generalization of data. Such networks, neural nets are constructed. So this could be a large endeavor, and then you use training sets, you use evaluation sets, you tune some meta parameters and so on. So this could be, I would say, a very challenging exercise on its own. Or alternatively, you can use just one fixed topology, very simple neural net, for example, with only one convolution layer and two fully connected layers plus input and output, a very simple standard one with not so big number of nodes, and you still apply it in order to get any preliminary sense of whether there is a useful information in this data. This is also a very important task. So this is the scope of data mining. Data mining does include statistical learning, various data pre-processing steps. It does include elements of machine learning, yet it is not a full in-depth machine learning. And then the question is, why do we need to spend 14 lectures studying this? If it is a lightweight machine learning, then we don't need to repeat what you have already got in your machine learning course, right? You already know about feature generation, labeling, machine learning itself, whether it is lightweight or not. If it is about data normalization, you already got something about data normalization. I don't know, maybe not so much, but it probably doesn't warrant spending the whole term for that. Descriptive statistics. Have you encountered descriptive statistics in your mathematical statistics or probability theory?
Actually,
Possibly. Yes?
actually, no.
Actually, no. So we would make an emphasis on this. Okay. Gaps, outliers. Okay. So, in my view, if we just go into an abstract study of, again, statistics, normalization, maybe empirical distributions, gaps detection, yes, we can do that, but it would be a very dull course in that case. We really need something very exciting. We now know what data mining is all about. Yes, it is about statistical preprocessing and some lightweight machine learning, mostly to decide the data applicability for further learning. We already know that, but we need some kind of challenging application area which would make all these things interesting. What do you think? Where all these terms we put on our whiteboard would really make sense, would require non-trivial techniques, would really be meaningful, useful, exciting, challenging, interesting, worth studying. And such areas do exist. We'll do one of them, and this is called quantitative finance. Quantitative finance is about data which are financial time series. Where are these financial time series coming from? Any ideas?
Maybe bank transactions.
We're not, well, it could be, but
Stock
unfortunately,
market.
yes, unfortunately, bank transactions, although it would be a very interesting area to study, are not available to us. We're going to get financial time series from financial exchanges. Not only stock market, for which asset classes? Yes, stocks. In financial terms, they are called equities. It is called equity market. FX, and maybe other financial instruments. But equities and FX, and in particular FX, are our primary objects of interest. And for FX, there would be our beloved FX instruments, which we're all concerned every day with, and that's the first thing which we look at 10 o'clock in the morning. I will explain why 10 o'clock in the morning, which is called USD ruble exchange rate. Right? That's the first thing we would look at. Where is this USD ruble exchange rate coming from? Where does it come from? Ultimately,
Birja. I don't know how to.
Exchange. Birja is exchange. We say financial exchanges. Okay, which exchange?
Like money, valuta.
Currency exchange. From currency exchanges. Actually, we'll talk about this in detail next time. I will give you an introduction into exchanges and related information. There are many different types of exchanges. Some of them are really exchanges in the legal, from the legal point of view. An exchange from the legal point of view is a very heavily regulated exchange place, which is under very close scrutiny of the government because of its financial importance and importance for the general economy. There are other exchanges which are less regulated, which are called ECNs, electronic communication networks, which were set up by the banks in order to trade currencies on interbank markets. But for this USD ruble in particular, the most important exchange from which this rate is mostly coming, and that's why it is called a rate settler exchange. Rate settler means the most important one, is the currency section of the Moscow exchange. Moscow exchange. In short, abbreviation is MOEX. Currency section of the Moscow exchange. In the past, before 2011, there was no Moscow exchange. There are two different exchanges in Moscow. One of them was called MICEX, Moscow Interbank Currency Exchange, precisely for the currency. And another one was called FORTS. Actually, it was not even FORTS, it was RTS. RTS, a Russian trading system. They merged in 2011 to form Moscow Exchange, and currencies and equities as well are in the MICEX section, and currencies from MICEX became the currency section of the Moscow Exchange. Equities obviously became the equity section of the Moscow Exchange, and RTS is now a part of MOEX, which is responsible for derivatives, futures, and options. We may or may not have time to consider them in our course, but we'll definitely start with currencies and also consider equities if possible. Now, this USD ruble, interestingly enough, you may or may not heard about that, is not a unique financial instrument. There are two closely related, actually more than two, but two primary closely related USD ruble instruments, which are USD ruble with delivery today and USD ruble with delivery tomorrow. What does it mean with delivery today? When you make an operation at the Moscow exchange, so for example, you buy $1,000. $1,000 is the minimum lot you can buy, no less than 1,000. At a certain current exchange price, 74.00, for example. So you buy USD 1,000, pay rub 74,000. All right. when exactly would these rubles be subtracted from your ruble account at the exchange and 1000 USDs received on your USD account at the Moscow exchange. In order to trade at the exchange, you open an account either with the exchange itself, if you are big enough financial institution, or with a broker which is also associated with the exchange. In any case, there would be your ruble account and your USD account. When you buy USD, then USD come to your USD account and rubles are removed, subtracted from your ruble account. But when does it exactly happen? Moscow exchange typically, this currency section is open from 10 a.m. to 23:50. So if you make a trade, it doesn't mean that $1,000 are received on your currency account immediately. Not at all. It happens at a so-called clearing time after trades. So when you make an exchange trade, it is not a fully committed trade yet. Well, it is a commitment from the legal point of view that you are obliged to pay 74,000 rubles in exchange for $1,000, which you will receive. But this transaction is not made yet at that point. If it is USD ruble with the delivery today, then the actual transaction based on the price fixed, for example, we do it right now, this price 74,000 is fixed right now. But the actual movement of rubles and dollars would occur at or after 17:30 today. At 17:30, trading in this instrument, USD ruble with the delivery today, is finished. And after that, clearing or settlement of trades, of all trades which happened within the day, would occur. And for example, it might be that you bought $1,000 and then subsequently after a few minutes you sold $1,000 but at a slightly higher price. In that case, dollars would not even be moved first to your account and then from your account. What you would receive is just the differential, hopefully positive, of rubles on your ruble account. So first, there would be a so-called netting of all transactions performed by the exchange, and then the exchange will decide which accounts to increment and which accounts to decrement in rubles, dollars, euros, and so on. And that will happen after 17:30. Whereas if your instrument is USD ruble with the delivery tomorrow, then as you could probably guess from this term tomorrow, this settlement would occur only tomorrow, which means that your position, so for example, you are now long because you bought $1,000 in dollars, you short. Short means that you are obliged to pay 74,000 rubles, but this doesn't happen anytime today. This doesn't happen even at 23:50 today. Instead, you will wait until 17:30 tomorrow for this transaction really to happen. And that's important to notice because we'll consider in our analysis both instruments. They have special codes at the Moscow exchange. This one is called USD 60 rub. And sorry, no, today rub is not even part of the name. USD 60 stood, and this one is called USD 30 UTS. Don't ask me, I don't remember what UTS stands for. Tomorrow. and similar for Europe. Okay. We will analyze in very detail time series which are publicly available at some price, but they're available, and I made them available for you to download from Yandex Disk. They're big. There are 20 gigabytes of compressed data for 3 months. For 3 months. Unfortunately, the data are not very recent. It is March, April, May 2018. Unfortunately, the data have a price tag on them, so it's not possible to buy them for every month, not yet at least, but we'll have that data available for that period of time. In order to understand what these data are about and how we're going to, first of all, construct statistics, perform cleanup, perform format preprocessing. This is a very important thing actually, and so on. You will need to understand the notions such that order book, order, trade, obviously price, which is abbreviated to PX, quantity of order or trade, order types, and so on. So what is it all about? This is about mechanics of exchange trading, and also a term which is called market microstructure. Mechanics of exchange trading and financial markets microstructure. We'll talk about this first of all in your labs today. So there will be a preliminary discussion of these notions, and then there will be a detailed discussion in the next lecture. But we're done for today. At least we know what is the subject, problems, and objectives of data mining, the position of data mining in other data science related disciplines, and we have agreed that we'll study data mining using extensively examples coming from quantitative finance, in particular time series for financial instruments traded at Moscow Exchange. Thank you. If no more questions, if there are, I would be happy to answer them.
Actually, I have a question.
Yes, please.
When we will get our syllabus with our criteria, with our works we need to do?
Oh, good point. Good point. Yes, you will get it shortly. In general, as it was last year, I think we'll do same this year. This course is project driven. So there will be lectures in order to introduce you to the concepts we are going to apply. And then you will be using your favorite programming infrastructures. That's what we are going to discuss during the labs today. It might be Python or C++, probably still Python because it is most democratic, although not most efficient and available to everyone, in order to implement data mining, a sequence of all interrelated data mining projects. That's what we are going to do. And there will be no final exam by itself. Only you will need to defend your projects implemented throughout the term. So the course is obviously does include lectures in order to introduce all the concepts and theories and methods to you, but it is primarily project-based. Okay? Still,
Okay.
and your syllabus will be very closely connected to data mining in quantitative finance. I'm going to publish it soon. It might be before tomorrow, or if not before tomorrow, then after our lectures on financial markets, order books, and microstructures tomorrow.
May I also have a question?
Yes, please.
Did I get it correct that our project will be based on the data set you are going to release today or tomorrow?
Exactly, yes.
Okay, thanks.
So please prepare the space available in your notebooks. So it would be at least 20 gigabytes of data, or possibly more if we move into other asset classes. So for example, from currencies to equities, then you would need even more space. Okay. And this, by the way, will highlight one of important aspects of data mining is how to make meaningful results, obtain meaningful results, including some, I would say, some lightweight machine learning using only moderately powerful computers like your notebooks. So you wouldn't be able to have, let's say, large gigabytes of RAM. So you would need to devise one-pass memory-efficient algorithms, obviously CPU-efficient algorithms, and so on, in order to achieve your objectives. Data are big, but you don't have a supercomputer to process this data. Yet it is possible by devising, let's say, O of n, both CPU and memory, in terms of CPU and memory utilization algorithms, to achieve all these objectives on your personal notebooks. That's what we're going to do. Okay?
Excuse me, is this project going to be a group project or a single person project?
You can discuss it during the labs. Last year it was individual, but I would not mind if you do it in groups, provided that groups are not too large. So let's put the upper limit to the group size to be 4, not even 5. So 3 to 4. 5 is already a little bit too big. And yes, you can do it in groups like that. In groups of no more than 4. 3 preferred. Okay?
Okay, thank you.
Thank you. Any other questions, please?
Just to clarify, but we can do it alone, not in groups.
Whether you can do it alone? Yes, you can. Yes.
Okay, thanks.
Which is a particular case called group of 1. Tomorrow we meet at 9 a.m. for a lecture on Zoom as well. And then the following week it may or may not be a face-to-face lecture, or it might be a distance one as well, depending on my circumstances. All lectures are recorded and put on YouTube. So this one will be compressed, put on YouTube later today, and you will be able to review it. Okay?
Can you also please share the board?
Yes, yes, definitely. We do it as well. So this whiteboard will be. I will put it into Moodle, and also put links in our Telegram channel. Our Telegram channel is the primary means of communication. So please stay tuned. All announcements related to labs, related to lecture schedules, discussions of tasks, questions, please discuss in this Telegram group. If you have a question, for example, related to the format of the model, it's better to ask in the group so that not only yourself, but everyone who may have a similar question actually would get an answer. Okay. If no more points to discuss, then we're done for today. Thank you very much once again for attention. And now you go for your labs, and the next lecture is on Zoom, 9 a.m. tomorrow. Thank you.
Thank you. Goodbye.
Thank you.
Thank you.
Goodbye.
Goodbye.
Bye. Bye, everyone.